Hello, and welcome to Assignment 3 of Web Application Engineering.
So in our first assignment for this course, we designed an application using a single servlet that handled a lot of the processing of the parameters and passing of information to the JSP pages in the presentation layer. Along with the processing of the database using an XML parser, this is fine for small web applications, but less suitable for larger applications. Assignment 2 involved a change from using an XML dataset to a database and implementing a design pattern, in this case MVC architecture, which would better streamline the application. MVC comprises of a model, components that allow database access and retrieval of information such as DAOs and DTOs, a controller, which in this case is a servlet, that handles the flow between the various components in an application, and the view, in this case all the JSP pages that render the retrieved information. Using this design pattern, processing can be predominantly kept off the JSP pages and inside the model. In our assignment, the controller executes commands which run the DAOs that access the database and returns the records to the command classes and then back to the controller, which then redirects the requests to the view. Moving on from this, we will now talk about the API, design, architecture, and DAOs that we implemented in our assignment. So APIs. So as part of our application, we implemented a set API that would allow URI mapping in the servlet, which followed a hierarchy. Looking at the diagram, you would go from any of the JSP pages up the top, flow through to the servlet. So within the servlet, you would have these URI mappings that would point to, that would be evident in the URL bar when using the application. For example, anything that came under the admin account would start with /admin, as can be seen here, followed by the specific sections such as admin users manage, which makes it evident that as an administrator, one would be managing users in the view. The administrator would only be able to perform specific commands from this mapping, such as searching for users and viewing the list of all users matching the search, and would have specific results returned from the model to the controller. The administrator would also be only viewing the specific JSP page that is rendered from this mapping, as can be seen here. So as we followed the MVC architecture for our assignment, we separated all our processing from the view and the controller and implemented it all in the model. Our view comprises of JSP pages that incorporate little in the way of scripting, and with Ajax to incorporate updates on the JSP page without redirecting to another page. This can be seen in our chart as seen up here. These JSP pages will render all the results specific to the URI mapping that we have. Following from this, if a JSP page has performed a GET method, the form would follow the API and map to a specific part of the servlet. Following the controller pattern, we set up a variety of commands that have been hash mapped upon the servlet loading. These can be seen here in our chart. In this example, we have user login, search term, admin ban, and search graph command, to name a few. So moving on, each command can instantiate a DTO or a bean, instantiate a DAO, which is another design pattern, perform a method from the DAO, which would run a prepared SQL statement object on the database and return a variable that can either be a result or a boolean. In our code, we've highlighted here a DTO that has all the user variables in our admin get user command. Later on, we've passed these results through an admin user DAO, which goes off and collects, runs prepared SQL statements to find by nickname, first name, last name, email, customers, and sellers. These results are then passed back to the servlet and utilizing a variety of different methods, and a user DTO is then collecting all the results, and then the request parameter sets all these attributes, which has all the results that have been found. So following on from that,
we showed that with the results are stored in either a bean or a DTO, which is a data transfer object, or simply passed as a type and stored as an attribute ready for use by the page that requires the information. So to access the database, JDBC drivers, known as Java Database Connectivity Drivers, maintain a constant connection to the database, enabling the prepared statements to be executed. In this assignment, we utilize Database Access Objects, known as DAOs, as part of the model in order to provide specific information depending on the parameters passed from the view layer. DAOs have implementations which perform SQL queries as inputs or returning outputs on conditions and returns these as types to the command layer, where they can either be taken as inputs to DTOs or simply passed back as a request attribute to the controller and then forwarded to the presentation layer. So in our assignment, we have here the DAO factory. These maps all the implementations to the DAOs that we have instantiated. So here we have the user DAO as an example. This has all the return types and what is passed to each method. And then we have the implementation, which has the prepared statement as seen here. And it gets the shared connection instance that has already been set up to the database. And then we have the user list DTO, which is then what is added at the very end of the request statement that has been run. This is then returned to the command, which then returns all the results back to the servlet and the controller, which then returns back to the JSP page itself. So all of this enables real-time access that is specific to what a user has requested and can be used to manage large data sets whilst keeping all the processing server-side to avoid potential security issues. So looking more closely at database access objects in a visual format, here we have the user login command. This command will then instantiate a user DTO and a user DAO. This will then go to from the DAO. It will then access the user table within our database called Bookstore, which is a MySQL type database. It will then run the prepared statement, return the value to the user DAO. This will then pass all these results to different parameters within the user DTO. This will then be passed back to the login command, and then they will be set as attributes to be passed on to the servlet. Okay. So now looking at the database tables that we have set up in our assignment, we have quite a few, and that we utilized MySQL as our database type. For users, we have covered 4 different tables. We have the user table, which stores a list of registered users. As can be seen here, they have the attributes of user ID, username, password, nickname, first name, last name, and email. Moving on from here, we have a table called login sessions. This login sessions has all the session attributes that for when a user logs in, and it keeps track of who is currently logged in as well as their session IDs. Another table we have is the admin table. This table contains a user ID, level, and timestamp, and it maintains the list of users that have admin privileges. We also have another table called admin login sessions, which has the ID, timestamp, user ID, as well as the session ID, which stores the active login sessions for each admin that is currently logged in. Okay, so now we'll be talking about the book transaction tables, which we have 3. The first one is called listing. This stores a list of publication details, search book functions, and which will query from this table. And we set it up to have pub ID, title, authors, editors, type, year, venue, seller ID, picture, price, status, sold count, and timestamp. These two all to uniquely identify each book the same book can be sold by multiple sellers. We will now look at the cart table. Cart table stores items that have been added or removed from a cart, stored by user ID, pub ID, the add time, and the remove time. We also have a transaction table, which stores all the payment history and is uniquely identified by the buyer ID, seller ID, so each one has a pub ID attached to those particular tuples. We have, within the admin section, we have 4 tables that are specifically set up. We have the band table, which stores a list of band users, simply identified by the user ID and the timestamp. We have the IP log, which stores unique IP addresses specifically for analytics, which has the IP address and the timestamp. We have listing statistics, which stores listing count statistics for analytics and simply is identified by pub ID, added to cart, and viewed. We also have a table called page hits, which stores page count statistics, also once again for analytics. So we're now looking at graph in terms of the tables that are associated with it. Graphs section stores data for graph visualization. This will be explained more in detail in the next section. It covers 2 tables, 4 views, and 1 store procedure. So looking at the entity table, this table stores all the nodes and edge attributes. It is uniquely identified by the ID and includes pub ID, entity ID, class, which defines node, whether it's a node or an edge, the type, as well as a caption. We also have another table called graph. This stores all the relationships between the nodes and the edges by linking the node from to the edge and node to. We now have a view called graph node from. This adds the entity ID of node from into a view by joining the graph and node table specifically by using the node from ID, node from caption, the edge, and the node to. We now have another view called graph edge. This adds the entity ID of an edge into view by joining the graph and the node tables, which includes the node from, edge ID, edge caption, and node to attributes. We now have the graph node to view. This adds the entity ID of a node to into view by joining graph and node table specifically. And this also includes node from, edge, node to ID, node to, and a node to caption as the attributes that are used. So looking now at the graph output view, this is created from joining graph node from, graph edge, and graph node to into a single view for using query graph when performing a search graph function. We now go to the list node, which is used specifically for finding all nodes that link to an input node. You can type in a value, and this is specifically returns a result which gives you the node ID. We also now have a final table called variable. This stores other important values of the system, such as the order number, as well as the value itself. So now I'll be talking about graph visualization. The concept behind it is that a node will be an object for an author, a publication, venue, and a school, while the edge will be objects that show the relationship between the nodes. We use alchemy.js for displaying graph at the front end, and a store procedure for recursively finding all objects that are related to the search results. So we have the graph store. These are 2 main tables that store the graph data, as we mentioned earlier. The first one is the entity, which contains all the nodes and edges attribute of the graph. One record contains only one node or edge attribute. The class is either a node or an edge, whilst the type is object type, such as the author, publication, venue, school, directed link, etc. The second table is the graph table. This contains all the relationships between the nodes of the graph in ID format. And then we have 4 views that make displaying and getting the graph results easier. From here we have to search the graph, and in general, the graph search functionality is similar to book search. However, the most difficult part of searching the graph is how to get all entities that are linked to the search results that we get. This could be done by using a store procedure to do breadth first search. So using a store procedure, you can use existing store procedures to perform a breadth first search, which has the steps as follows. You get the starting node list as the input. You then add the unique nodes, which are children of nodes in the list. You then add unique nodes, which are parent of the nodes in the list. And you repeat the past two steps until there are no more unique nodes to add. This image here on screen just shows how the nodes can be linked between each other and how they can also be separated. So we have edges which link the nodes, which are the relationships between the nodes. So visualization of the graph. Alchemy.js is a JavaScript library that is based from d3.js. This aims at being a pre-configured version of d3.js. It needs a graph.json format as an input, which looks like what is shown on the screen to you, and some certain configurations to start everything off. So just as a word of thing, the most stable version to currently use is 0.3.1. So useful configurations are as said below. The forced lock configuration, the graph height configuration, the graph width configuration, the show control dash configuration, zoom controls, specific node types, which can have labels and is a list of the different types of nodes, the node caption itself, and the node style, which follows a certain format as can be seen on screen right now, with the color, border width as part of publication, but is formatted for each different attribute such as publication, author, venue, school, and that's it. So we now have another configuration called curved edges. This makes all the edges in particular curved. Directed edges make the edge that has a direction. Link distance function, which determines how long the edge will be. And then we define the edge style, which is determined by affiliation, the published in, authored by, and edited by. And using alchemy.begin configuration allows us to render the graph. So now looking at the final results of the graph, we will now visualize the graph itself. So here we have on our assignment, and then we can go and visualize a sample plot. So now searching for Lin, this now returns all the relations associated with Lin, including where Lin occurs in a name and what publications as well as the venues that Lin can be potentially linked to. In this here we have the green node representing a name, we have the blue node which represents the venue, and we have the yellow node which represents the publication itself. And as you can see, there's not too many here, but we also have an affiliation for a red node as well. And these can all be moved around and changed. So doing another sample search for publication, example algo, it doesn't have to be the actual full word. We now return all the relations between all the occurrences of algo. And once again, you have all the venues, you have all the authors, as well as all of the publications and potential affiliations. One final search is by venue, and we will search for computing. This doesn't return back many, and you can see that the relations here have been kept separate. So anything that is part of computing informatics is lower relation is specific to that one, and for the top one is also specific to that one. So I'd just like to thank you from all 6 members of our group for listening to our presentation summary of our assignments. I hope it has provided useful. Thank you very much.